explain. So you see, if you just check the format, it's very simple. On the top, you'll find the general information. On the right, again, some general information. Next, this is psychometric condition, design condition and the condition space parameters. We'll update this. Next, you see this section is for solar heat gain through glass. Okay, sensible only. Next, this section is for wall and roof heat gain, transmission heat gain. Means conduction and radiation. We'll discuss about the formula, same formulas. Next, this section is for, and you see, we are talking about the sensible only. Latin you'll find separate section. Next, this section is for partition floor and ceiling, including the glass for conduction. You can find here all glasses, and this for conduction, we can add the area of all glasses. That says in the term is given all glasses. In some cases, you may find the different values, but mostly in one project you'll find same type of window. So for conduction, whatever the orientation, we can add the area. This. Next, partition floor and ceiling. This for this section. Next, this section is for infiltration and ventilation, but ventilation, you see, with bypass factor, because you see we are talking about this room heat gain. You see, after getting the room heat gain at the end, you will find the fresh air requirement, that too for contact factor. So the bypass factor heat is a load of space, so that's the reason here the ventilation you will find, but with the bypass factor. So for example, 100 CFM I'm considering in this sample project. So 100 multiply with the 1.08 multiply with the, this 1.08 multiply with the CFM into delta T. So here CFM, delta T and 1.08, and if I multiply with the bypass factor, say 0.12, the result will reduce to 12%. Means 12% of ventilation heat sensible I'm considering in space. Similarly, you'll find the 12% of ventilation heat latent also in the space. You see, here also you'll find the bypass factor, but this section is for latent, again fresh air. Means the sensible latent bypass factor heat we are considering in the room heat. Why? Because you see, here A plus B is a effective room total heat. Okay, so we are adding this bypass factor sensible latent heat before getting the total total room heat. After that, we are adding the ventilation load. That too, you see, contact factor here. We are using contact factor here. So this is a load of ventilation which is directly on the coil. Hope you're getting my point online.
Can you explain, sir?
Simple, yes. Simple. Already we conclude that the heat from that bypass air is a load of space, na? For example, you see this is space, and here is a unit. For example, means the coil. So when the air passes through this, the air which touches, I'm talking about the fresh air, because this bypass and contact considering for fresh air, because the room air is going to circulate, na? So it's not a load of load on the coil, load on the space, because all the spaces again gets supplying back to this. And but continuously we are providing the fresh air. Okay, so that fresh air CFM, first when the passes through the coil, some air touches to the coil, so that is a contact air, that is a load on the coil, right? But the bypass air directly enter in the space, so it's a load of space, right? Again in the return it will become a load of coil, but first is a load of space, na? That's the reason this fresh air bypass sensible, fresh air bypass latent, we are calculating in what? Room total heat. Okay. After getting the room total heat, we are adding the ventilation load, and ventilation load nothing but base because of this contact factor. Because you know this, already we discussed, the ventilation load is a load on the coil, it's not a load of space. But now the new thing is, from the ventilation load, the air which not touches to the coil will become a load of space. Right? Clear?
Yes.
But here you see one more question here. Why we are doing this? Finally, we are adding all this thing, na? Because at the end we'll find this ABC, means room load plus ventilation load is a coil load. So why we are doing so? Because we require separate room load and separate total load to find out the CFM in to find out the dehumidified CFM and total CFM. We require this separate information. Okay, so that is also one reason we are doing this. And this is a carrier method to get the CFM. So we require all this as separate value. Like we require separate A, separate B, and A. This C. C is nothing. C, and we have ABC. C is a ventilation load. A is a room sensible. B is a room latent. C is a ventilation. So ABC is a total coil load. Okay. Clear online?
Okay. So this contact factor into 1.08. So
1.0 is a factor. The formula is 1.08 multiplied with the CFM into delta T, na? And this 0.68 QL is 0.68 multiplied with CFM into delta W. Here the new thing is a contact factor. Okay. Similarly, the new thing is a bypass factor. You see here also 1.08. Multiply with the CFM, multiply with the delta T. Here 0.68 multiply with the CFM, multiply with the delta W here, means humidity ratio. Here the new thing is bypass factor. So finally we are calculating the pressure load for 100%. What we are considering, say for 100 CFM. But we are considering the heat because of the bypass air as a space load, and the heat because of the contact air as a directly coil load. Okay. Clear online?
yes, sir.
Yes. Next.
Yes, sir.
So let me just complete this section first. What are the different sections? So you see here transmission, then infiltration and bypass air for considering for fresh air, this section. Next, this section is for internal loads, people, lighting and appliances, including power if applicable. Power means motors. Next, this section is for latent, and after getting the sensible latent, we'll get effective room total heat, A plus B. Then after that, this section is for fresh air, contact factor. To get the total, and the right side, you'll find section for ventilation, infiltration, means CFM, and also to get the total air CFM. This section is to find out the total air CFM based on the psychometric formula, and this formula is again from Carrier. Carrier means originally from psychometric analysis only. And in the previous session, we calculate the supply temperature, and the supply temperature also we'll use here in the calculation, and we got 59 degree Fahrenheit to get the CFM. Okay, so anyhow, let me just proceed with this. This is very simple. So simply I'm going to use the same sample project using Excel sheet. Okay, so let me arrange. So on the right side I can get the inputs. And here you can verify after the class also. This I'm going to zoom on this left side first. Sorry, I need to update this psychometric condition first. You see outside temperature for your project, 106 now. And room temperature what we are maintaining for summer is 76. And when you enter, you'll get the difference. Similarly, wet bulb. So wet bulb, I think 79.5. The same I'm going to use from the input. Remaining values also you can verify. You see 79.5. But we have some more points to discuss related to this outside condition. At this level, wantedly I'm holding this because in actual practice for advanced, means for some projects, you'll find two different trials. But what I consider in manual, peak dry bulb, peak wet bulb. But with the peak dry bulb, you'll get mean coincide wet bulb, and with the peak wet bulb, you'll get mean coincide dry bulb. So we'll discuss that case at the time of software. Wantedly I hold because in manual, to be safe side, both the values will consider as peak. dry bulb as well as wet bulb. But in software, with the dry bulb, we'll consider mean coincident wet bulb, and with the peak wet bulb, we'll consider mean coincident dry bulb. So don't get confused. That topic is I have not explained clearly yet. But in manual, we'll be following this. So I'm using the 79.5 RH and other factors you can find out later. And room RH we are maintaining 50%. So I need delta T and delta W. Remaining parameters with the psychometric chart or software you can update after session. Now we require humidity ratio. Outside humidity ratio, I think you remember we got I think 110, right? We calculated in the class now at the time of heat gain through ventilation infiltration. And inside 67. Okay, quickly let me confirm. At the time of heat gain through ventilation, people see for ventilation here, W and WI sensible. Sorry, you see 110 is WO, 67 is WI. You know how we got this, considering the outside and inside condition with the psychometric chart. So here you see the difference is 43. This is delta W, this is delta T. And this white color means directly based on the formula, and the Excel will use the same throughout this load calculation as per the requirement. You can notice here automatically update here 30, 30, 30 and 43, 43. This is delta W, this is delta T as per the requirement. But for partition floor and ceiling, you can verify here. Here I'm getting 25. This white color means not the user input. Automatically I'm getting. So L18 minus 5, nothing but partition floor and ceiling, you know, unconditioned unconditioned temperature minus conditioned temperature. Unconditioned is what? Outside minus 5. So outside minus 5 minus condition 25. Here you see. Or is directly 30 minus 5. So here 30 is L18. Right? Next. So now let me proceed with this. So first section is for heat gain through glass sensible. Very simple. So for our sample project, we have two glasses. So you see, in manual calculation, we start with the conduction, but in the Excel, you will find directly from radiation, heat gain through glass radiation. So we have two glasses. One is at north side, one is at west side. So I'll confirm all this. You see, heat gain through glass. Conduction, you'll find here all glasses, but at present we require radiation. For radiation, you see solar heat gain, north and west. So we'll use the same. So north area, you know, you see north area is 28 na? Sorry, my mistake. Here 28 is actually U array.
So 28 is solar radiation.
Yes, yes. So here area is 20 here, right? So 20. Then this delta T here, just for format is given delta T, but this is not delta T. This is solar heat gain for 1 square feet sash area, and I think you know we got 28 from the data book page number table 15, right? You want me to show this 28 with the latitude we got with the timing, latitude and all. Okay, and you see this U is not the overall coefficient of heat transfer, because we are talking about this radiation, so don't get confused. This U we are considering as a factor. It can be overall coefficient of heat transfer, or it can be a shade coefficient. Okay, so we bother about SHGS, solar heat gain coefficient, right? And we got 0.75. 0.75 considering ordinary dark color glass from table 16, right? So the same. So 0.75, and you can find the Q. You see 420. The same value is matching here. So let me speed up. So same thing, just I'm confirming with this Excel. Now west glass area, you know, 28. Delta T from the table, I think you remember at evening time we got 163. The same you can find here, 163 at 4 p.m. and U means factor 0.75 and Q is 3423, the same. Next, scala is applicable. Yes, so scarlet area is 4. skylight delta, this radiation heat gain for 1 square feet, I think remember we got 251. You can verify here, 251. Considering the noon time. Okay, just for your confirmation, quickly I'll show you one example. Already I shared this table. You see, table 15, but this is 0 degree, so we bother about 90 degree, 20 degree as per our budget requirement. You see, in the month of May, here noon time 250, right? Similarly for west 163, and for north, where's the north? Here 28, right? Some consultants follow 8 am and 4 pm as the standard time. So instead of 28, you may find 23, because you may not find everything peak at once, na? Okay, so don't get confused, but as per the concept, you should follow the peak from this 6 am to 6 pm. Okay, but most commonly many consultants, they are in manual calculation, this they are considering 8 am and 4 pm as a standard time. Okay, so don't get confused, follow as per your consultant if they are following 8 am or 4 pm, because it's a manual, you cannot expect 100% accuracy. Next, back to the topic. So 251, factor is 1. Why 1? Ordinary no shade. We consider clear glass, right? Next, for this wall, very simple. We have 3 walls, north, west and south, right? So you can verify from here, you see. The calculation, directly jump to calculation. You see north, west and south. So I'll update the same. So in this equivalent temperature, that should be means the corrected one. So area for north 80, still we are dealing with manual, so I'm considering net area only. Next, delta T nothing but in this case ETD corrected, so don't get confused. This delta T is common for all, but as per the requirement to consider. So we got you see 14 plus 12 is a correction factor, 12 is a equivalent temperature based on the standard table, and 14 is a correction factor, right? So I'm using, my mistake again. North, for north we got 14 correction factor plus 4, so I can consider 18. Next, U value 0.49, what we already calculate. Next, for west, here I got the Q. Next, directly west wall, right? Sorry, in the list here first is south, so let me consider south 100, and south wall 16 plus 14, so 30 is equivalent temperature, corrected one, 0.49 U value. Here 1470, you see exactly is matching. Next, quickly for west area 101, and then 26, right? Equivalent temperature plus correction factor 0.49. Door is applicable. Door area 21. Equivalent temperature for door 40 plus 14, 54. U value for door 0.39. You can verify everything from the right side. Next, all glasses. Here all glasses means conduction. And for conduction, the area of glasses we can add what we did at the starting. You see, here we consider 48. You know the reason. So area 48, and you see here the formula. U is here, area delta T, and how I got this delta T, 30 from the beginning, and 0.86 is a U value, right? Next, partition area 150, and directly delta T is given here 25. Why? How I got this? Because the white color and with the formula input. And U value for partition, I think 0.52. Next, ceiling. Ceiling area, roof width. Ceiling area is 76.66, and the ceiling UL is 0.27.
नेट में भाग देता सर
Floor 150
रिचार्ज मार दी क्या
and the value 0.32. Skylight, here you see skylight we did in this radiation, so contaction also applicable. 4. And then skylight U value. Skylight U value I think 0.4 something. 1 minute. 0.48. Next. Now, so in order to get this, you see this also white color, so we need the CFM and the location you can find Q33. So you need to update this. So let me zoom this first. You see, we'll update this information, ventilation CFM and infiltration CFM, so that the Excel will directly use in the calculation in the left side. So for ventilation, people and area method, this originally this Excel is from format is from originally from Carrier, so I follow the same here. If you want to use ASHRAE method, then I'll share one more Excel. In that you'll find you see ventilation as per ASHRAE format, people, area and the summation. But in this case, when I click here on the total CFM, okay, let me update this. Here you see number of people 4 and CFM per person from the data book, table 45. I think we got 25 CFM, right? So you see 100. Next area 150. Sorry, my mistake. 11. Okay. 0.25 square feet per the CFM per square feet. Multiply 150. 150 already have given it the input, so here we'll catch. So that is 1.5. So now what will be this value? We consider the higher between the two, right? So I'm going to enter 100. So when I enter 100 here, you can notice on the left side it will update 100. Okay, we'll use in the calculation. Similarly for infiltration, we use crack method, right? So for door 21 into 1 CFM per person. In that last session we did a commercial door 1 CFM per person, 1 CFM per square feet, and for residential 0.5 as per the table. So you see 21 CFM. Next, crack. This for feet means this is for window. So we require window perimeter multiply with 0.37. So window perimeter, I think we got 1 minute. I forgot 1 minute. Let me verify.
No internet.
13 plus 20.
No internet.
41.
Mobile में connect
perimeter. CFM we got 36. So yes, 41 is correct. So 36.17 you can out of to 36, and you see this 36.17 you can verify. It will automatically update here. Excel program. So now we'll continue. So you need to update this also so that the Excel can use in the calculation. Next, ventilation infiltration, there is no confusion. Directly you can relate with the formula. And you see, still we are dealing with a sensible load only. Latin you'll find the separate section. So you see formula 1.08 multiply with the CFM multiply with the delta T. Here is a Q. No confusion in infiltration, right? Same formula. But in ventilation, you see 1.08 multiply with the CFM multiply with the delta T. Here the new point is a bypass factor. But when I click here, you see bypass factor into 1.08. But how the Excel is using this bypass factor? When I click here, you see you can verify B46 nothing but CFM, E46 here delta T, here Q21 is a location of bypass factor. I'll show you. Multiply with 1.08. You see, even this 1.08 here written is only for information. This location is what? H46 na? In the Q there is no H46. So 1.06 only for information. In the Q you will find this 1.08. Sorry, 1.08 is only for information here. In the Q, in the formula is given 1.0, which is means based on the product of this what specific heat and but specific heat and density of air. You know this factor. But Q21 you can inspect. Q21 is a bypass factor. And what I'm assuming here is 0.12. And this again blue color means user input. So when enter 0.12, you can notice you'll get the contact factor 0.88. Okay. Because 1 minus bypass factor is a contact factor, right? So when you give the input here, automatically, as per the link, you see, here Q21 is a location. Hello. So here I got the Q. And this 388.8 is a ventilation heat gain sensible, that too based on the bypass air only. Means only 12% of the total sensible ventilation load. Right? And you know why we are considering this. Already we discussed at the beginning. Because still we are talking about the room heat na. Can I proceed online? Next you see. Next section for internal heat, very simple. Number of people. You see from where I got this 25. 1 minute. I think I did a mistake here. Acha, I shuffle this. This is 25. This is 24. Anyhow, the result is same, but this 4 is what? O. You see, O24. This Excel is using the same location here for getting the number of people. Here I am getting this. You see, O24 na. So people heat gain, you know, and still we are talking about sensible. 4. N into here is user input. So this is sensible. You'll get from data book page number table number 48. As you know 245 we got in manual. So 245 multiply with the 4, 980. Right. Next, lighting. This is the formula for lighting. 3 point wattage into 3.4 multiplied with the area. If you're using the density, this wattage density, the same formula here. But where is the ballast factor? I'll show you. But first of all, you see 150 is the area. Here I need to enter the density, wattage density. What we got from LPD table from ASHRAE, 1.11. So 1.11 multiply with 150 will get the total wattage. Here multiply with 3.4. But where is the ballast factor? So ballast factor you can find out in the Q. So when you inspect the Q, here you see 1.25. And if 1.25 means this is for what? Fluorescent light. In case of incandescent, delete this. Okay. As per the Excel format. Okay, so don't get confused. Next, you can create one more section here for ballast factor to avoid confusion, but this is a direct because most commonly in actual practice we'll get, for most of the project we'll get fluorescent light now. Anyhow, you can prepare your own. Next, equipment. We need the total wattage. So that multiply with 3.4 will get BT per hour. So how to get the total wattage? I need to get from this manual calculation. Appliances. We need to do some calculation because here we did direct na. So I need only the total wattage because we are talking about here sensible. And you see this 700 latent will use in separate section. So I want only sensible. So here you see 66 watts multiply with 4. Next 26 watt multiply with 4. And next 433 watts multiply with 1, so 433 only. Next this 500, what I got is a BTU per hour. This is not the watt, so this I need to convert into watts because this 700 is a latent, but this is sensible. But sensible in the data book we got in BTU per hour. So this 500 I need to convert into watt. And this motor HP, this is directly in BTU per hour. And this also I need to convert into watt because this also sensible na? Okay. So first of all let me get this 66 multiply with 4. sorry, 264, 26 with 4, okay.
801.
But now 3220 plus 500. So this is 37 and this is BTU per hour. So how to convert this into watt? Divide with 3.4, right? Divide with 3.4. 1 minute. Something wrong. कुछ गलती कर रहा हूँ मैं.
1094.
अच्छा, 1000 only. Okay. I'm reading this as per lakh. Okay. 1094 plus 801, right? 801. Here I'm getting 1895 watt watts. So directly enter 1895 here. Sorry. Here. 1895. It will multiply 3.4. You'll get Q. So this is sensible only. Latin will cover later. Next. Now here you see HP I covered directly in the wattage now, because from data directly we got BT per hour. So that BT per hour convert into watt and I'm using here. So no need to use this HP. Or else if you know, but directly you cannot enter the HP also, because you need to consider the motor efficiency, and considering the case you need to get the result, and in that table you will get BT per hour. Okay. We discussed this different cases now, motor and the machine inside or outside, or motor inside, etc. So that's the reason I consider directly here in the wattage that motor heat also. But in case if the machine is of 1 HP and completely inside the room and the motor is outside, so machine 1 HP means directly the heat gain from machine we can consider 1 HP. In that I can enter 1, so 2545 will get the result. Okay. So, but in our case, what we consider both inside the space. I think you can able to relate my point. Yes, online?
Sure.
So now you see when I enter all this from above, you'll get subtotal. You see summation of I-19 to I-51, all this. And you know this what we discussed in the previous session, 10% safety factor. So these are 10% of above value. And these are total of this both. This is a total, this is a subtotal of sensible and safety factor, and this is effective room sensible heat, and this I am considering as A. Okay, so first part is done. Second part is for latent. Third is for fresh air. Latent, you know, limited sources, people, lighting, and appliances if applicable. That for appliances. Here, including infiltration. And you see 0.68, you know, QL equal to 0.68 into CFM into delta W. So here 43, from where we got this, you know, from the beginning. Here 43, this is delta W now. So for infiltration, same 0.68 CFM delta W. But for ventilation, again I'm using bypass factor. You see, and this 1.68 is only for information. This 0.68 you'll find the calculation. 0.68 into Q21 nothing but the bypass factor again into E57. E57 is what? Delta W multiplied with B57 is nothing but the CFM. No confusion, na? So this 350 BTU per hour is a latent, that too because of the bypass air, which is directly entering in the space and becoming a load of the space, like the sensible above. Okay. Next, number of people is 4. Latent heat gain, you know, 205 from data book, table 48 or 45. You can check in the notes. Next, appliances. Here in appliances, we have a coffee maker, right? Then the coffee maker 700 is directly BTU per hour, right? So when you enter this 700 here, the same value will get on the right side. 700, you see 700 BTU, because directly BTU per hour, no conversion. Now this is a subtotal of all these four values above, means latent. Now we are considering 5% latent as safety factor. So this is 5% of above value, and the summation of both. Here I'm considering B, which is effective room latent heat, right? Now finally we're interested to find out the ventilation load because of this contact factor. You see here when I click here, 1.08 into contact factor, but again this is only for information. This factor and contact factor here will get in the result. You see Q22 is a location for contact factor. You can verify here. You see this is Q22.88. So in the Q value you'll get this contact factor. Q22 1.08 also you'll find in this Q only. This is only for information. Remaining 100 CFM 30. You can verify B56 and E65. Okay, CFM, delta T, then contact factor 1.08. Contact factor means 88% sensible heat due to this fresh air is here. Similarly, this is 88% of latent, considering this delta W is here. And the sensible plus latent contact factor due to this ventilation air, I am considering this as C. So finally ABC is a total coil load, na? Right? You see AB is what? Effective room total heat. C is a ventilation load. So total ABC I am getting here in terms of BT per hour, and this value divided with 12,000, 2.85. So let me quickly check with our manual. You see what we got here, very close value. I think we got 2.87. Here I am getting 2.85. Which format change? Okay. You see 2.87. Here 2.5. Why this slight difference? It's online.
Plus factor and contact factor.
Yes, because you see here directly 10%, 5% we consider as what? Total room heat. But in this case, this 10%, 5% even for the bypass air, na? So that's the reason slightly difference. See 0.87, very less. Any second digit even you can ignore. So 2.85. This is the tonnage, but this is not the end. We required the CFM. And here in Excel, calculating CFM is very simple. If you enter all this, on the right side only you need to enter ADP, apparatus dew point temperature. But what is ADP from where? Where we'll get this, I'll show you. But before this, try to understand the format for this. You see ADP table is missing in that PDF, so I shared that ADP in the WhatsApp before starting today's session, so you can use that table, ADP tables. How to use you'll get in this video, and that is again from Career Handbook. This to find the CFM, here you see, you'll find the supplied CFM section from here up to this total CFM. This is a section for finding the CFM. So very simple. You see, first we are interested to find out ESHF, effective room sensible heat. And effective room sensible heat is what? Room sensible heat, nothing but A divided with A plus B. You see, effective room sensible heat. When you click here, you can verify the same. You see I-54 is here. You can check. You see 54I, nothing but A na room sensible heat, divided with what? I-54, nothing but A plus I-62. I-62 is B, right? Nothing but sensible by total room, not including the ventilation. We'll get ESHF, effective room sensible heat. We already calculated in the previous session also. Yes, we call as RSH, room sensible factor. Sorry, SHR, my mistake. We call as SHR and have given in the bracket ESHF because this EHF is a term used in carrier. So 0.89. It means 89% is what sensible, remaining is latent. In the manual we got 90%. 1% difference you can ignore. Now, after this, the next step we are supposed to find out ADP. This is a new term. Apparatus dew point temperature. Nothing but the temperature. Apparatus dew point temperature means the dew point temperature of the cooling coil. So this we can get from the data from carrier handbook because this method belongs to carrier. So how to get this? In order to find this ADP, we require two parameters. One is a ESHF, what we got just now. That you see, this is ESHF. Okay, effective room sensible heat factor. With the ESHF, so using ESHF with room condition. Room condition is what? 76 degree Fahrenheit with 50% RH. With this parameter, you can find out ESHF from the table number 18 from carrier handbook. So let me open the same from carrier handbook. You see, these are all table number. Sorry, my mistake. Not table 18, table 65. So you see, table 65 start from here, but with a different room temperature 90, 82, 81, etc. We are looking for 76 degree Fahrenheit. So the 76 degree Fahrenheit table is here. You see, dry bulb, room condition dry bulb 76 with the RH what we are considering standard as 50. Now using this parameter 76, 50, this is the column now. So what we got is 0.89 ESHF. You see 0.8 close value 9380 close values here. This is ESHF. Below this will get ADP. Okay. Anyhow, if you want, you can interpolate this point for 0.93. I'm getting 55 for 89. Can you find out this? 0.89 divided with 0.93 multiply with 55. Can you please calculate this? 54 point something. Is online. 52.63. 52.63. So I'll go for 53. So this is indicated. This is selected. 55, 53. Now when you enter this, you will get the next parameter automatically. That is dehumidify air rise. Nothing but the increase in temperature because of dehumidification on the coil. When the air passes through the coil, when the air passes through coil means it will touch to the air. I'm talking about contact factor, contact air. So what will happen? On the coil you will find the dew point temperature, and because of dew point temperature, air loses the moisture on the coil, and because of that, the increase in temperature, right? Or else you can verify here with the formula also. You see, room dry bulb minus ADP. So apparatus dew point temperature what we got just now here 53, room dry bulb 76, 76 minus the ADP. So 76 is the room temperature. So this temperature passing through the coil and loses the moisture. So minus ADP is 53, and this dehumidified air rise or dehumidified CFM because of contact factor, right? So you see, yeah, when multiply with the contact factor or 1 minus bypass factor or contact factor, both are same. So you get the value. This is a formula base, so don't get confused. This is as per the carrier. So here I got 20.24. It means because of dehumidification, increase in temperature to that coil is 20.24, and using this value we can find out how much air loses the moisture on the coil. Nothing but dehumidified air quantity or dehumidified air CFM. Again based on the formula. These are all again formula based on the psychometric analysis. So you see, room sensible heat divide with demultiply air rise, what we got just now, multiply with this 1.08. So room sensible heat, effective room sensible heat, nothing but A. Or else you can verify in the form in this Excel also. When I click here, you see here I54, nothing but A na, by Q41. Q41 is here, nothing but demultiply air rise with 1.08. So I got this 1177.85 CFM. What it mean? It mean out of the total CFM, this much of air loses the moisture on the coil. So we can call this as a dehumidified air CFM, and this information required by the manufacturer at the time of coil selection. You see, for fan selection we require the total CFM, that we'll get next. But for coil selection we require the tonnage and this dehumidified CFM also. Apart from this, some more parameters for big units like AHU or high capacity package that you'll find in HAP report. Okay. Anyhow, these are the major parameters. Next. Following online?
Yes, yes.
Yes, sir. Next. Yes, please.
One.
Yes, online. Following this? समझ में आ रहा है आप लोगों को?
Yes, sir.
Yes, sir. Okay.
Questions.
Yes.
Yes, sir. We're dealing with only one space, but in actual practice there will be a lot of space, like multiple spaces. So on that case, for every space we need to check with this Excel sheet.
Yeah, you see, load calculation is base, means we'll do space by space. If it is 100 space, you need to go for separate 100 calculation.
Alright.
Even in
that we need to maintain on summary sheet.
Yes, you need to maintain summary sheets. If you are supplying, for example, all the spaces you are supplying the air with the 1 AHU. In that case, we'll take the summation. Again, in that case, you need to go for the block load CFM also. That we'll discuss later. Because at a time, all the space will not get the peak. So we'll go for the block load CFM instead of the peak CFM. We'll discuss that point. Even in
For example, we're doing calculation for this one space. Later on, we're using same Excel sheet for another space, right? So if I need some modification in the previous calculation, then I need to enter all the data once again. What exactly we need to do?
Yeah, you see, Excel is like a manual only. You need to spend time on this. But most of the time, these values are similar. So, if, for example, if the location is Hyderabad, you can use this. So, what you can do, you can update all this and use only enter the area. So, when you enter the area, you'll get the Q. Remaining will be 0. Just to save the time. But anyhow, Excel is like a manual only. You cannot expect like software. So you need to spend time for this. This is for small and medium type of project. For big project, suppose say 50 spaces or say 100 spaces or a high-rise building, you must go for a software, HAP software. Even in software, you need to prepare all the spaces, and later all the spaces will link to the system as per the zoning. That is also a bit lengthy, but compared with manual, that is, you can save up almost 70% of time compared with this manual. Anyhow, after software, you'll get the clear idea. But load calculation, you see, even with the software is a lengthy task. But in Revit, this is all these external sources will automatically capture by the software. Only you need to enter the internal sources, because in Revit we are dealing with the 3D modeling of the building, and again in Revit, if you are using CAD file, the load calculation is not applicable. You need to use the 3D intelligent building. Then only the software can extract all the possible external sources for the spaces. Only from your side as a user or as an engineer, you need to input only the internal sources, because that software cannot extract that one. Again, in internal also, the lighting appliances can extract by the software if the electrical load is already done. Anyhow, that is another story. But even with the HAP, you need to spend time for the load calculation, because load calculation is one of the lengthy and complicated tasks. That's the reason in actual practice, after completing the load cal, after extracting the data and entering in the HAP by one engineer, then is going to verify, and they must miss in actual practice they are verifying by a senior or other engineer. It's must, because definitely there is a chance of mistake. So QC is required for this. Okay, anyway, at the time of software we'll discuss more about this. So next,
can you please show how to maintain that summary sheet? Do you have any format?
Summary sheet, no problem, I'll show you at the time of equipment selection. It's a normal Excel. In that you'll find the format. You need to enter space 1 the parameters, space 2 parameters, and all this parameter will get from the HAP report, and that will